All right, we're going to look at organ transplant operations, the economics of that. As most of you know or may know, there's a federal law that bans paying for these operations. All right, so we've got a problem in the market in that the quantity supplied is typically not as much as the quantity demanded at that price. All right, so here are our graphs to connect, first of all, the organ transplant operations market over on the right with a starting point of you can't do an organ transplant operation without an organ to transplant. So we've got on the left the organ transplantable organ market, kidney, heart, okay, organ A, okay, just as sort of a generic marker. All right, one of the first things that we see that we have to put on here correctly is that we've got to shift the supply line over so that it intersects the x-axis. So in other words, we have to put on here the reality that we see, namely that folks are willing to donate organs. Okay? Most of the time we see supply and demand graph, we see the supply line connected to the y-axis that says it takes a minimum price before any will be supplied at all. Not the case here. At a price of zero, folks are willing to donate a certain amount of any given organ, but typically not enough. Quantity demanded at a price of zero, okay, is way over here. Now, the price by the time it gets over to a clinic may be a little bit more than zero, so it might be a little bit smaller shortages than that. But in most cases, we see shortages. So, just for the sake of our numbers, to connect these two graphs, let's talk about this. And the quantity supplied by donors, okay, at a price of zero, is 27. All right, and if we allowed the market to work in the sense that we would pay folks enough so that the quantity available is the same amount as the amount desired, okay, then in our graph we would see a price of 5. Let's use single-digit numbers to keep it simple. It's in thousands, okay, so 5,000, but we'll not say the 1,000 part of it, okay, and at that price we would see 61 organ A, 61 of those provided by somebody, either if it's a kidney, they don't have to be dead to provide the kidney, or by somebody that signed an organ donor card. I guess if we allowed price, it would be an organ provision card. Their estate would get this money. Okay, so that combination would yield some quantity supplied, and at this price, the amount available would be the same as the amount desired. All right, so we carry that information over to the organ transplant operations market, where the suppliers are the clinics and the demanders are folks in a bad way, that whose quality of life or their very continued existence of their lives will depend on the availability of an organ for transplant. Or if it's a kidney, you know, then get them out of dialysis, for example, so that they're a little bit more independent, and among other benefits. All right, well, we see in the right-hand graph, this 27 carries over to here, right? Based on the cost of these operations, up to 27, okay, the supply is going to reflect that. Somebody out there is willing to do one of these operations for $10,000, okay, one. Okay, it'll go up from there based on opportunity cost up to this level, and then, well, the opportunity costs continue to increase, hence the dashed line, but, you know, we can't, this isn't a realistic part of the supply line if the amount of organs for transplant is restricted to this quantity 27 here. So we get this vertical supply line. S1 is the initial supply given the federal ban on paying for these organs that limits us just to the amount donated. All right, but I made the line dotted because presumably, you know, maybe it's curved, maybe it dips that way, but just for the sake of simplicity, suppose the opportunity cost of providing these operations increases at a constant rate. Okay, so we get that dotted line here. But that's only realistic if we start allowing payment for these organs, right, to get from the 27 up to a larger quantity. All right, so suppose we repeal the federal ban on payment for these organs, and now we have 61 organs available per year, okay, and everybody, even those who would otherwise have donated, is going to be paid the $5,000. All right, so that yields this red line. Notice that it diverges from the dotted line, reflecting the opportunity cost of doing the operations, but without having to pay for the organ. Okay, so that captures this piece of information, namely that as we move up the supply line, right, from 0, we get additional organs available. Okay, so, but then we have to pay, right? So that difference, which could have been larger in my graph between the dotted line and the red line, eventually gets us up here to P sub 2. My graph's getting a little bit crowded, where the opportunity cost of the operation is 37. The operation costs 42 because we have to pay this $5,000, the 5, to the provider of the organ. Okay, so at the new equilibrium, okay, the price where the new supply intersects the demand, okay, we see the price is $42. 5 of that belongs to the organ provider. The other 37 actually goes to the clinics. We see in this case, there's ways to draw this to not get this result, but it would be hard. We see in this case that that's a lower price than would result from rationing out just the 27 donated organs. Right? With just that few organs, they could charge for the operation $56,500. Okay, but just 56.5 drawn here to get some thousands of dollars for that many, for 27 transplants of organ A. Okay, so a lower price and some money from the organ providers if we allow the market to work and provide 61 organs in this case rather than 27. All right, 42 minus 37 yields the 5 that's over here.